Hello guys, welcome to Speedlabs, and today we will see what is free body diagram, FBD. So it is one of the most important concept that we need to understand, because with the help of this concept we used to solve different types of numericals. Basically this concepts is very useful in order to solve numericals. So today we will see how we can make a free body diagram of an body. Okay, so first let us see what is actually free body diagram, then we will see how we can the steps that helps us to make the free body diagram of a particular object. Okay, so basically free body diagram, it is nothing, you have to just keep this thing in mind. You have to make a separate diagram representing the body is by a point and draw vectors representing the forces acting on the body. Remember this point, this is very important point bachcho. You have to keep this point. You have to draw vectors that are representing the forces acting on the body with this point as a common origin. So basically it is nothing free body diagram. It is a diagram in which we shows the force, the various forces which are acting on the body, not the forces that body acts to other object. We will not show this thing in free body diagram. We just show the forces that are acting on the body in free body diagram. Okay, I will just give you one very good example, and why that you can understand what is the meaning of free body diagram. Okay, so before this, let me give you a very basic example so that you can understand. Okay, so here let us consider a table. Let us consider a table. This is a table, let's say. This is basically a table. This is basically a table, and let us say a block is kept on this table. Understand? Let us say a block of mass m is kept on this table. Now I will just ask you one question, that what are the various forces that are acting on this block of mass m? Okay, so I'm drawing that forces. Okay, the free body diagram, in free body diagram, the first step that we just draw one point. Understand? The first step, the very first step, you have to just make a single point. Okay, now you can see that the table will exert one normal reaction to this block, and that will be perpendicular to the surface to the table, है ना? And the other force is that Mother Earth will attract this block by mg. Okay, so there are basically two forces. First force is a normal reaction. This is a normal reaction denoted by n, and other force is acting in a downward direction, that is mg. Understand? Only two forces are acting on this body, and I have drawn these two forces, normal in upward direction and mg in downward direction. Understand? And as you can see, the block is at rest. There is no horizontal motion. Understand? Neither a vertical motion. So I can say this normal reaction in previous example, this normal reaction and this mg will be equal. Why? Because there is no horizontal motion. N is equal to mg. So with the help of this free body diagram, we can write such equations. Understand? This is a very basic example. Now a good example I can give you. Suppose, let's say there is a rough surface. There is a rough surface in which a block of mass m is kept, and there is one boy. Okay, consider here, we can also consider this example as a good example. Here, see this boy is basically applying the force in this direction. Understand? So if I want to draw the FBD of this diagram, what I will do, I will just mark one point. Understand? This surface will exert a normal reaction in upward direction. This is n. Okay, so I will point out n here. This is n. Now this block is attracted by our Mother Earth in downward direction, that is mg. So this is my mg. Now this man is applying some force to this block, understand, in this direction. So this will be force applied by this block, understand. And at the same time, when there is a relative motion between this surface and this block, the friction starts acting, because frictional force is a contact force. It always exerts when there is a motion, and this types of friction is especially known as dynamic friction, and this will act as opposite direction to the direction of motion. It is shown by F. Understand? So basically this thing, as you are seeing on the board, this is the free body diagram of this particular case. Okay, as you can see, there is not a motion in a vertical direction. There is vertical direction, it has no motion. It is just sliding on horizontal direction. So what I can say this normal reaction and this mg are balanced, because there is no movement in vertical direction. So from this I can write equation that n is equal to mg, first equation. Now see, the boy is just pushing this block in right hand side direction. This block is moving right hand side direction. It means this applied force is obviously greater than this frictional force. So as I told you in my previous videos that net force is equal to ma, that is Newton's second law of motion, understand. So what I can write, this force is obviously greater than this force, so the net force in horizontal direction I can write here, that is force applied minus frictional force. This is net force, and that is equal to mass of this block and acceleration produced. This is my second equation. So what I actually want to say, that free body diagram, with the help of free body diagram, we can easily write the equation of motion and solve particularly the question needs to ask, understand. So remember this thing. Now I am just taking one good example for you. Just by this you can be very much clear with the concept of free body diagram. Okay, consider a pulley like this. Okay, and there are two blocks. First block is of mass m1, okay, and the second block is of mass m2. Okay, now I am just taking one condition, that m2 is greater than m1. m2 is greater than m1, so it is obvious that this m2 will come downward and this m1 will come upward automatically. Okay, now as you can see, this is a string, this is inextensible string and massless string. We will consider it, and tension will act like this here, understand. This is the tension, understand. So if I want to draw the FBD of particular this block of mass m1, so what it will be, just see. Okay, I am just making this the free body diagram of this mass m1. Okay, so I will just first make a point here. Okay, now our earth will attract this mass m1 in downward direction with m1g. Similarly, a tension is acting on this block, that is T, understand, and there is an acceleration of block in this direction A. This is not shown in free body diagram, this is shown particularly in different side. Okay, so this is basically the free body diagram of this mass m1. Similarly, I can draw free body diagram of m2 also. Here m2, earth will attract like m2g, and similarly there is a tension T in upward direction. Now as you can see here, m2 will move in this direction particular with the same acceleration, because they are attached with the same string. So with the help of free body diagram, I can write the equation. How? See here in m1 case, this is going upward. It means the tension force has effective resultant. So what I will write, tension minus m1g, this is net force, and that is equal to m1a. Similarly, the m2 block is going downwards, so the effective force m2g is greater than tension. So I will write m2g minus T is equal to m2a. And by solving these two equations, we can get the value whatever the question is asking. You don't need to worry about it. So basically this is all about free body diagram. Understand? In free body diagram, we just mark all the forces which are acting on the body, and we just write the second equation of motion, that is F net equal to ma. Understand? This is very simple. Very simple. Understand? Yes. So this is all about free body diagram. Understand? Okay.